Okay, welcome to Chapter 7. Chapter 7 is going to be dealing with lines and angles. Okay, so when you're going to be doing this chapter, specifically this unit, you're going to need a ruler and you're going to need a protractor, and you're going to have to know how to use a ruler and how to use a protractor and how to measure the angles using a protractor. Okay, so a lot of this is going to be reviewed from your grade 9 math, so let's just go over it very quickly. Name each of these in triangle ABC. You can see we have a triangle. It's labeled A, B, and C, and you can see there's a point P on one of the line segments. So name one of these a point. Well, the only point on there is point P, right there. A line segment. Well, a line segment is what we call the names of one of these lines here from point to point. So we could say that from A to B is line segment AB. An angle, well, let's start with A. We could say that this is angle A. So the way we write it is like this, angle and then A. And a vertex, well, vertex is just one of these points at the end of a line segment. So we could just name any vertex A, B, or C. We'll just label one B. Okay? Double the measure of any angle, so just take your calculator, take these numbers, multiply them by 2. That's what it means to double, so I'll just do one of them, 28. You can take your calculator and do the other 3. Just put that number in and multiply it by 2. Determine the measure of each angle here. Well, half of 172, basically just take this angle and divide it by 2. Okay? So you can take your calculator, take 172 divided by 2, and you get an answer of 86. Okay, so you can do the other one. That's what it means to take half of a number. Calculate the measure of each angle. Well, 360 divided by 2. Well, just take your calculator and divide it by 2. It's the same as this one. Half of 172 is dividing it by 2, and this is the same thing as saying half of 360. 360 divided by 2, obviously 180, and you can do the other 3. Determine the measure of each unknown angle. 37 plus what number equals 90? Well, the fastest way to do this is just take your calculator and take 90 and subtract 37, and that equals 53. Okay, so 37 plus 53 equals 90. All right, you can do the other one. Match, number 6, match each type of angle with its description. Okay, so a right angle. We all know that a right angle has a 90 degree angle, has this symbol in here, the little square, the box in the corner, so let's match it up. So a right angle is simply just a 90-degree angle. Let's just draw a little arrow to that one. A straight angle. Well, we know that if we take this 90 degrees and we drop it down so it's a straight line, okay, that's basically half a circle, and that gives us an angle of 180 degrees. Okay, so a straight angle is just an angle that measures 180 degrees. An acute angle. An acute angle is less than 90 degrees. Okay, an angle less than 90, up to there. An obtuse angle is one that is more than 90, but it's less than 180. It's less than the straight angle, so it's in between 90 and 180. An angle greater than 90 but less than 180. That is called an obtuse angle. So these are a couple of terms you're going to have to remember for the next 3 years of math, acute and obtuse. Okay, also right angle. And a reflex angle. Well, we only have one answer left over. It's an angle that is greater than 180 degrees, so it passes the straight line, but it's less than 360. And 360 is how many degrees there are in an entire circle. Okay? Go on to the next one. You're going to need a protractor. So if you don't have a protractor, go to your teacher. Get a protractor. I'm sure your teacher has lots of them in a drawer somewhere. Use the circular protractor diagram to answer questions 7 to 9. So determine the number of degrees in each one whole circle. Well, if we start here at 0 and we go all the way around the entire circle, you can see we go from 0 back up to 0, and that's 360 degrees. So there's 360 degrees in a full circle. Half of a circle, well, that's just a straight line, cutting it right through the center, and you can see we go from 0 to 180. That's our straight line angle. And a quarter of a circle. In other words, we take this circle, we cut it into 4. So if you cut it in half this way and cut it in half this way, a quarter of a circle here is just our right angle, 90 degrees. Because if we take 90 plus 90 plus 90 plus 90, or 90 times 4, we get 360. All right, question 8. Draw a 25-degree angle on the circular protractor. Mark the arc and label it 25 degrees. Okay, so we want to go to 25 degrees, so we're going to start at 0 and we're going to go to 25. We know that we want to go from here right to the center of the circle, and then we take your ruler and make a nice straight line. I'll do as straight as I can. That's not a very straight line there. Now go up to 25 degrees, and then it says mark the arc. Well, to mark the arc just means we just do this and write in 25 degrees. We have to make sure we have that little circle beside the number that signifies degrees. Okay? On the circular protractor, draw the hour and minute hands of a clock to show 10 p.m., mark the arc, and label to measure the angle. Well, we all know what a clock looks like. We could say that right at the top it says 90 degrees, so we're going to write 12 o'clock here. And over here, this is the 3 o'clock position. Down at 270, this is the 6 o'clock position. At 180, this is the 9 o'clock position. Now, we want to mark a 10 o'clock position. So between 9 and 12, we know there's 3 hours. And between 180 and 90, we know that there is 90 degrees. So if we take 90 degrees, we divide that by 3, we're going to get 30. So that means from 180 we go 30 degrees, 10, 20, 30, right here. That would be the 10 o'clock position. 10, 20, 30, that would be the 11 o'clock position. And then we go another 10, 20, 30, that's the 12. So we can say that this position, 10 o'clock, right here, at that angle, is the 10 o'clock. So it says mark the arc and label the measure of the acute angle. So we'll go from 12 o'clock down to 10 o'clock because that's what they're asking us to do. They're asking us to measure this angle in here. Well, we're starting at 10 o'clock is 150 degrees, and at 12 o'clock it's 90. So if I take 150 degrees and I subtract 90 degrees, that gives me an angle of 60 degrees. So that means that each from 10 o'clock to 12 o'clock is 60 degrees, okay? Which means that each hour, 12 hours, each hour on the clock is going to be 30 degrees. And if we take 30 times 12, we get 360, okay? Which gives us the full circle. What 3 angle measures are shown on the chair diagram? Well, let's do this one right here. That's a straight line, so we know that's 180 degrees. We've got this angle in here, so we can say that we have a 90-degree angle in that chair. And then we've got this angle from the seat all the way down to the leg. That's a reflex angle right there, and that's going to be the full circle of 360, but subtract this 90 is going to give us 270 degrees. Okay, so those are the 3 angles that are shown on this chair. Question number 11. Sketch each pair of line segments. We want a pair of line segments that are parallel but are not vertical or horizontal. And you remember what parallel is? Always the same distance apart, like train tracks, never crossing, never intersecting. Okay, but it says not vertical or horizontal. Vertical means straight up and down. Horizontal means level with the ground. Okay, so we're going to draw 2 parallel lines that are not vertical or horizontal. Well, we'll just put them at an angle. There we go. Any angle you want, just as long as they're not straight up and down or straight horizontal. A pair of line segments that are perpendicular but are not vertical or horizontal. Well, perpendicular just means it's a right angle. Okay, 2 lines that are right angle each other, but it says not vertical or horizontal, so we'll just draw it like this. One there, and we'll always signify a perpendicular angle by putting the little box inside the corner. Measure this acute angle using a protractor. So for 12, get out your protractor, put the line right on here from your protractor, and then find out where this line goes, and you'll see that it reads, I read it as 18 degrees, okay, from the 0. That means that it went up 18 degrees, almost to 20, but not quite, okay, when you read the protractor. Now it says determine the measure of the reflex angle. Well, the reflex angle is just the distance all the way around the other side, okay, and how do we do that? Well, we just take the full circle, which is 360. We subtract 18, and our reflex angle for this one is 342 degrees. Okay, so this is our acute angle inside here, and this is our reflex angle, the rest of it all the way around. Okay, so that's all there is for getting started on Chapter 7.